All right, so here it doesn't matter if we do IVT or Bolzano. I'm going to do IVT just because it's equal to a number here. So we do have to be a little careful because this function is not always continuous, right? So this function is actually discontinuous when x is equal to -2. However, -2 is not in that interval. So it means that we don't have to worry about this discontinuity, right? We only need the function to be continuous on the other closed interval that we're on. So in this case, 1 to 3. All right, so then we would say in the write-up that f of x is continuous on 1 to 3. All right, so if I'm using Bolzano's theorem, all right, so here's my f of x. Sorry, if I'm using IBT, so I'd plug in 1 and I'd plug in 3 and I'd see what those values actually give me. So if I plug in a 1, I'm going to get 1 squared plus 1 over 1 plus 2. That's going to be 2 over 3, so 2/3. Roughly, not rough, that's exactly equal to 0.6 repeating, right? So this value is less than 1.2. So I'm hoping f of 3 is greater than it. So I'm going to get a 3 squared plus a 3, 3 plus 2. That's going to be 9 plus 3. That's going to be 12 over 5, which is 2.4. So 1.2 is between them. We've bracketed 1.2 between those values. So therefore, we know that IVT holds. So if you want a neater, nicer write-up, just check the other nicer answer key that I wrote. In this case, we conclude this as something like, since x squared plus x over x plus 2 is continuous on this interval 1 to 3, and since f of 1 is less than 1.2, which is less than f of 3, the intermediate value theorem guarantees a C in this interval, 1 to 3, such that f of C is equal to 1.2. And that would be our conclusion.